Hi everyone. We are Group One. I am Murad Jafarli and my friend İlkim Mehmetli will present our data analysis report midterm homework for research project now. And let's start with our first slide. So you can see our dataset firstly. What we will talk about? We will talk about the arrhythmias from the Group 5, and you can see the three text there. For example, firstly, you can see the general data set, and you can see age, sex, height, weight, and BMI, and so on. Some data sets, and you can see our continuous variables. So our main work with this data set will be the age, BMI, as you know, body mass index, and heart rate, and finally number of intrinsic deflections about the arrhythmias. We will see these patterns with the absence or presence of arrhythmia. So, and you will see the arrhythmia incidence there. So, what we need there, we will give some examples. For example, in the first graphic, you can see the arrhythmia levels. 0 means there are no arrhythmia, and 1 means there's arrhythmia in this patient. As you can see, under the table, we can see 233 patients has arrhythmia and 198 patients has no arrhythmia, and nearly 431 patients we have, and you can see the percentage also and the frequency distribution graphic from this slide. So let's go on with the sex and difference. The sex difference generally in the arrhythmia patients and general patients. You can see once again the graphic and table. Graphic says again the 0. You can see the higher one, yeah. So 0 means man and 1 means woman in this slide. So 236 patients, main patients, are arrhythmia and not general patients frequency there. And you can see the frequency distribution graphic again there. So let's go on with the body mass index. My mate will explain us in there.
Hello everyone, my name is İlkim Mehmetli and I'll continue with body mass index. In this slide, we explored the relationship between body mass index or BMI and arrhythmia. Since BMI is a common indicator of health and body composition, we want to see if there is any significant correlation between BMI values and the presence of arrhythmia in our dataset. As you can see from the table, number 1 is underweight, number 2 is normal, number 3 is obese, and finally number 4 is overweight. So let's switch to the age difference. Age is another categorical critical factor when analyzing the health conditions. Here we compare the age of patients with and without arrhythmia to determine if older individuals are more likely to be affected. Understanding the age of distribution helps us identify at-risk populations. In our data, our age interval is from 17 to 84, and our median age is in this data is nearly 45. So let's switch to the heart rate. This slide presents findings related to the heart rate. We analyzed whether patients with arrhythmia had a noticeably different heart rates compared to those without. Since heart rate is directly connected to the heart function, this is an important aspect of our analysis. In our dataset, our average heart rate in our patient is approximately 84 BPM. So let's switch to our last data and last category. This category is number of intrinsic deflections. We looked at the number of intrinsic deflections in the ECG data. These measurements can indicate electrical activity in heart, and we aim to determine if there's any link between the number of deflections and the presence of arrhythmia. And this was our last slide. Thank you for your attention.